Okay, we're back for part 2 here. We're going to skip 3. We'll come back to that at the end. We're going to get down to this section here, 3, which says midpoint formula. Now, last class we talked about distance, and there's a distance formula. Well, the same thing is true for the midpoint. Remember that midpoint is another word for average. If we have 2 points, x1, y1, x2, y2, here's how we're going to do this. And I apologize, but somebody is cutting the lawn outside, so you may hear these noises here. We're going to set up a little coordinate plane. We'll go 1 to 5, and then on the y-axis, we'll go up to 6. And let's say I gave you 2 points. Let's say that we had 1, 2. And let's say we also had 5, 6. Now I know that my graph is not perfect here because these are not evenly spaced out. But let's see if this works. Okay, so there's the segment. If I wanted to find the midpoint of this, especially if I had graph paper, I could almost eyeball this. I could almost eyeball where the point is, and let's see, maybe somewhere around here. That kind of looks like the point. Now, one way we could do this and make sure of, look at the x values here. We have 1 and 5. These are the x's. If you look at the number line, here's 1 and 5. What's the middle of that? Well, the middle of 1 and 5 is 3. Okay. Now, how about the y values? The y values are 6 and 2. 6 and 2. What's the halfway point of 6 and 2? Well, that's 4. So this kind of looks like 3, 4. Now, what I'm really doing here, this is the answer, by the way. It is 3, 4. What I'm doing is I'm taking the x's and I'm taking their average. What's the halfway point of 1 and 5? It's 3. I'm adding those and dividing by 2 because 6 divided by 2 is 3. And then the y's are 2 and 6. What's the halfway point of 2 and 6? Well, it's 4. That's the average of 2 and 6. Add those up, divide by 2. 8 divided by 2 is 4. That's my midpoint. So here's, I eyeballed it. I actually got it, well, close to right. I mean, it's kind of, I didn't draw this well, but 3, 4 is pretty good, my drawing. It's close to 3, 4. Here's the formula. When you have 2 points, x1, y1 is 1 point, x2, y2 is the other. What we do is we take the average of the x's, we add those and divide by 2, and then we take the average of the y's. We add those and we divide by 2. That's the formula. Okay, so again, it's average, I'll say AVG, average of x, and average of y. And we always do the x's first because that's how we write our ordered pairs. Okay, we always write points x, y. So, number 4, find the midpoint of segment CD. Point C is 1, 1. Point D is 4, 5. I'm going to label, that's x sub 1, y sub 1, x sub 2, y sub 2. Midpoint is we add the x's, 1 plus 4 divided by 2, and we add the y's and divide by 2. That's 1 plus 5 divided by 2. I'll put big parentheses because this is an ordered pair. We're getting one answer. We're getting one midpoint, but a midpoint contains an x value and a y value. So x and y. 5 over 2, comma, that's 6 over 2, which we could write. Now, 5 over 2, you could keep that as a fraction if you want. You could say 5 over 2, comma, this is 3. We have to simplify if we can. It is also correct to write this as a decimal, 2.5, comma 3. So that would be your midpoint of segment CD. I like to write that, capital M is midpoint, and then segment CD. Find the midpoint of segment JK. Well, x sub 1, y sub 1, x sub 2, y sub 2. How do we find a midpoint? We take the average of the x's and we take the average of the y's. So midpoint equals, the x's are 2 and 10, so 2 plus 10 over 2, comma, the average of the y's is we add 0 and negative 4, and then we divide by 2. That's 12 divided by 2, which is 6. This is negative 4 divided by 2, which is negative 2. So there's your midpoint for segment JK. Now we've got one more here. For segment AB, A is 2, 3. The midpoint is negative 1, 5. What are the coordinates of B? What's the XY value for B? Now this one is a little bit different. What's happening here, I'm going to draw this. All right, let's see if this is enough. I'll just number by 2. Okay, so they give us point A is at 2, 3. They give us point M. They give you the midpoint is negative 1, 5. That's negative 1, 5. Now here's the problem. Normally they're going to give us the endpoints and ask for the midpoint, but in this case they give us the midpoint. Point B, if M is halfway between A and B, that means B is somewhere over here, and we need to figure out how to get there. Now there's 2 ways you can do this. The easiest way is really to count, to do this algebraically. If I start at A and I move to M, now the way I'm going to count is I'm going to go horizontally and then vertically. Okay, you could go up and left if you want. I'm just going to go left. So I'm going to count 1, 2, 3, and then up 2. Now, here's the deal. Left 3 and up 2 gets me to M. I don't know exactly where B is, but I do know that since M is the midpoint, this length and the length of M to B have to be the same. So however I count to get from A to M, left 3 and up 2, I have to count the same way to get from M to B. So I'm going to go left, 1, 2, 3. That's 1, 2, 3, and up 2. And that's going to put me there. And that is at negative 4, 7. Negative 4, 7. That's our answer for point B. Okay, so visually, again, what's happening is that they're giving us the midway point. They're giving us the midpoint. If we can count from here, we'd have to count the same amount on the other side. So this is a visual way of doing it. Now, we can do this a little bit simpler. Here's 2, 3 again. Here's A. I'm just going to write it out like this. Here's M, negative 1, 5. We don't know B, okay? We're trying to figure that out. How do you go from 2 to minus 1? Well, you would subtract 3 spaces, right? Go minus 3. To get from M to here, you got to subtract 3 again. You're going in the same direction. M is the midpoint, so you have to travel the same way in the x direction. Negative 1 minus 3 is negative 4. Look at that. Okay, now for the y direction, we started at 3. We're going to go to 5. That's adding 2. Well, to get to the other y value, we have to add 2 again. 5 plus 2 is 7. And there we go. So that's a little bit easier way. It's not quite as visual, but you're understanding that, hey, look, my change in x, my distance has to be the same, my distance in y has to be the same. The last way to do this, and this I think is the most confusing, is to actually use the formula. So where we take the average of x, we take the average of y, and in this case, we actually know the outcome. We know the midpoint. So what I would do here is I would take, they gave us point A, that could be my x1, y1. So 2 plus something over 2, and then comma y1, which was 3, plus my other y coordinate over 2 equals the midpoint, which is -1, 5. Okay, now what we have to understand is that this expression gives us the x coordinate of the midpoint. So we can make an equation like this. This has to be equal to -1. That's the outcome. To solve this, we can multiply both sides by the denominator, 2. That becomes 2 plus x equals -2. To solve this, we subtract the 2 here. -2 minus 2 is -4. There's the x coordinate. And then for the y values, well, this has to give us 5. So 3 plus, I'm just going to call it y. I don't need to write y sub 2. To get rid of the denominator, to undo that division, we multiply both sides by 2. Now these reduce to 1, so 3 plus y equals 10. Subtract 3, and what we get is 7. Okay, there we go. So you've got choices here. You can think your way through the problem, which is what you're doing here. You can do this visually by counting, or you could do it algebraically if you wanted. And that is the end of part 2.